Music theory, why the modal distance notation is objectively better than the scale degrees interval notation currently in use. What's the problem? I'll tell you what the problem is. The problem is that the current intervals system are unnecessarily, confusingly, and incorrectly using 3 different units of measure at the same time, dropping the most fundamental unit of measure from the term entirely. Why? Why would you do that? Making a devastating error on the second most fundamental measurement term in the measurement term. That's not good if you're trying to communicate with people. Stuffing an unneeded third measurement term in the measurement term, causing more confusion than clarification. These are problems, and I'm telling you, anyone that deals with this stuff for any long amount of time knows that these are problems. They just don't say it. It's like having President Joe Biden over drooling in a corner. Everybody knows there's a problem. Everybody knows there's a problem if they've dealt with this, but then they say, no, there's no problem here. I'm sick of the gaslighting, okay? I'm sick of the gas. You could take your gas and you can use it to drive off a cliff for all I care. Because I'm sick of it being used to gaslight me and other people. Let me tell you what I mean here. These are going to be measurement terms. Intervals are basically our unit of measurement terms. What's the baseline unit of measure within music? It's going to be the half step, similar to the inch being the baseline unit when we're measuring something in inches and feet. So the term, for example, of a major third, you will note, is missing the major unit of measure, which is the half steps. How many half steps are in a major third? You have to just infer it. So, I mean, you would think they would at least call it like a 4-note away major third, including the distance that is the baseline unit of measure in music. But no, they just drop it altogether. And then the 3 over here is a measurement term as well. We call that a scale degree measurement term. However, they made a mistake on how to measure when they used that measurement term. Because instead of measuring from the particular point that we're on, they used that point as the first thing to be measuring from, like measuring the top of someone's head if you're trying to measure the distance from the top of their head to the top of the basketball hoop. No, you measure from the top of their head. You do not count their head as foot number 1 when you make the measurement. It causes all kinds of problems to do that. You would think then the measurement term would be something like this. It would be a 4-note away third. That was all you would need. We have an added term as well, which is the major. You don't really need the major. You would think you already have 2 units of measure. It would be 4 notes away from the equivalent of inches, which are going to be half steps away, and it's going to be a third, even though that's a wrong way to measure because they messed up on where to start counting. It still kind of makes sense as a distance type of terminology, similar to measuring something and telling you the measurement in both inches as well as in feet. So that could be a useful thing, but why add the major? Notice what that's doing. It's really adding another measurement term. Notice what measurement terms are. All we're doing is saying, hey, look, this is our baseline, and now we're comparing other things to it. So we've determined a baseline distance of a note away distance, so now we can compare multiple distances by how many notes away they are. We have the scale degree concept, which again is kind of like a measurement as we're inside of a particular scale or collection of notes as a distance type of terminology, which is a little less perfect, but we'll talk more about that later. So this would be another term saying this is our scale degree units of measure that we're going to measure everything against. You don't really need that. It's going to add more confusion than clarification. Why? Because if I say something is 4 notes away and it's a third, then this third is implying that it's a measurement from a first of a scale degree. So that first might be the major scale, but it could also be the other 2 major modes, which would be the Mixolydian and Lydian modes. So by saying that I have a 4-note away major third or simply major third, when I'm not talking about a major scale, adds more confusion than you need. We already know that it's similar to the major scale. Why? Because it's a 4-note away third, and we know that that's the third in the major scale. So these are the fundamental kind of issues that cause a whole lot of problems, particularly on the guitar, but also on any kind of instrument. And let's address some of those problems here and think about how we might then add to the system so that we can add another term that will hopefully help us to clarify or see some of the problems that we might be facing. So objective, introduce a new modal distance interval naming system that uses distance and modal centers. So this is going to be just the common sense way. You might look at that and say, oh no, he's talking about modes and this is going to be confusing. He's doing some master class or something going way beyond no, I'm talking about measuring like a plumber would measure pipe or something, like the normal way to measure things. If you have the common sense way of measuring, that's what I'm talking about. This is the easy way to do it that we will then tie in and bridge to the current system so that we can see what the current system is doing and also be able to see what it's doing from a simplistic normal measurement standard. Thesis, the traditional scale degree system obscures logic and clarity. The modal distance naming system retains all of the benefits while correcting core issues. Now, if you're learning music theory, you're probably thinking, there's gotta be a reason. There's gotta be. And you've been looking, this cannot be the most optimal thing, but I'm trusting the system. But then if you look at it for long enough, you're like, no, you can do everything with a more simple system, really. So part of the reason, as we've seen in prior presentation, that the current system is the way the current system is because of the order in which ideas and tools have been developed throughout history, which means that if we were to reorganize things at this point in time, having all the tools laid out on our table, we would come up with something better, more efficient, most likely. So that's kind of like the explanation on why this is the case and why you might want to look at it now, in particular because we have tools such as a ChatGPT and other AI tools allowing easy conversion and to really check these ideas. If you disagree with any of my ideas here, copy the transcript of this thing, put it into a ChatGPT or AI, ask it if what I'm saying makes sense or not. Here is our fretboard. We have the low or heavy E string on top. I'm going to be repeating this analogy over and over because I think it's the optimal way to be visualizing things and it leads in perfectly to this measurement issue. So what's the best way to be visualizing the fretboard? I'm going to say it's a map of the territory, similar to the globe. Here's our globe down below. And like on the globe, we're going to say that there are 7 continents, 7 destination locations. Now, there's actually 12 locations on the fretboard, but the non-continents, the 5 non-continents, we're going to say that those are like the oceans. Those are the things that we go through, not the ones that we're going to basically want to be landing on. If we take our perspective from space, we're up here above the fretboard. Our head is looking down on the fretboard. We are in space. We can imagine the fretboard is rotating to the right, like the world, like the globe rotating around. We're going to give it 12 degrees of rotation, naming those 12 degrees of rotation based on the notes in the musical alphabet. And now we're usually going to be working in the collection of notes related to the key of C. However, the whole thing would shift forward. If I went to C sharp, to D sharp, this whole thing would shift forward. All the relative positions would remain the same, just as you can imagine all the relative positions on the globe remain the same as it spins around from your perspective in space. So that means once I know the perspective I'm looking at, I no longer want to name them, the notes, by note name. I want to name them by the continent names, which is equivalent to the Nashville number system if you have used that system. The Nashville number system basically simply just using a number for the node locations, the Ionian, the Phrygian, the Lydian, the Mixolydian, and so on and so forth. That is the most optimal way to be visualizing the guitar, to open up the guitar most easily, not only in one key, but be able to shift through all 12 keys and rotate through all modes in all 12 keys. Now, there's a problem with that, and that is that the current naming convention is based on scale degrees and based on using the major scale as our reference point, as we have seen, right? So it's using our measurement term of scale degrees, which is going to force us to rename terms as we talk about distances, as we build chords. We want to recognize that so that I can try to break down the relevant information of the name, which is simply distance, not scale degrees, so it doesn't make me or force me to think I have to rename the fretboard, give me a misunderstanding of where I am within the continents on the fretboard. That's going to be our general idea, our general problem. We also, in our term, measure everything or compare everything to the major scale. So in other words, you'll note that the intervals will either have a major, a minor, a perfect, or an augmented or a diminished term within them. What happened there? Basically, we compared everything to the major scale, and everything that didn't fit into the interval of the major scale, we called something else, like a minor or an augmented or a diminished. That's really kind of like a unit of measure. That's like saying my foot, I'm going to compare everything to how long my foot is, and that's going to be my unit of measure. We don't need that other unit of measure, however, because we're already using 2 units of measure, which is more than enough, which is going to be the half steps, as well as what I'm going to call the modal distance, which you can also call the scale degree distance. So in other words, if I'm measuring from this point, then I would call this, from a Nashville number system, the 5th or the Mixolydian mode. So I don't need to call it the first. If I want to go from here to here, how far is that? It's going to be 1, 2, 3, 4 notes away, but the term typically used is a major third. Well, if I say major third, that would imply that this is the first, which is not what I want to do. I want to keep that as the continent number 5, Mixolydian continent, and it would also imply that we're in the major scale because it's a major fourth away, but we're not. If we're going to use scale terminology, we would be in the Mixolydian scale measuring from this point. So that those are confusions that are introduced into our mind, which shouldn't be introduced into our mind, but for the confusion of the name that is in place. What would be a better system? If it would be better if I just used the unit of measure from this point. It's a 4 node away from this node, the Mixolydian node, or instead of using scale degrees, it's 2, 1, 2 modal half steps, or units away within the collection of notes. So instead of calling it a scale, it's a collection of notes that's in order. I can measure from any of those nodes. It's basically a circle that goes around in a circle, but I can measure from any of the nodes within the circle. So if we take our continent kind of concept here and we apply it to the fretboard, this is what I first applied it to. This is position 5 through 8. And this is what I would call position number 1. That's why I applied it out here first. I just took the continents and applied it out. So we had North America, Europe, Asia, South America, Africa, Australia, and then Antarctica. Now, in between those continents, we have the oceans, the ones that we're not going to be spending a lot of time on, but might touch on as pass-through notes as we're moving to the continents. So here's an ocean here, an ocean out here, an ocean here, here, and here. So we have 5 oceans within our example that kind of maps roughly on a global idea. Now note, when I pull this into practice of actual measurements, we want to put this more in a circle format. So if we're measuring distance, there's 2 ways that we want to be visualizing it. One is we have a clock kind of format, so we're going to measure it as we go around in a circle. And the other is that we have like a note number line that goes infinitely up at this point. We can also go backwards. We'll talk about that in a second. But first, it's going infinitely up, let's imagine. So that makes the map even easier for us to think about, because instead of us being able to cross the middle of the map to go from South America to Asia or something like that, I can only go around in a circle. We have a block kind of format. So that's going to be easier for us to visualize. So if I look at a clock face, let's start at the 2 right here. I'm starting in South America, which is the 2 in our example, and I want to go to the 5. There's 2 ways I can do that distance-wise. I can count from continent to continent, 1, 2, 3. It would be 3 continents up that way. Now notice what the scale degrees are doing. The scale degrees are making continent 1 or continent 2, continent 1. I would measure this as the 1, like the first inch in our, right? 1, 2, 3, 4. It would be the fourth scale degree up. That's not how you normally measure. How you normally measure is from that point, 1, 2, 3. So the concept we're going to introduce is modal half steps, which are like continent to continent. There's 3 steps up from this node. I don't need to rename the node to measure 3 steps up. Then if I also want to add the oceans, which aren't in between each note, they're going to be in between some of the notes, which we'll talk about more when we get to the examples, but that would be 1, 2, 3, 4, 5. So it's 5 total distance, including the oceans, which would be equivalent to the note distance up, and 1, 2, 3 modal half steps up. So that's going to be the measurement term ideas that we have. Now note that we can also go backwards. We can go 1, 2, 3, 4 negative modal half steps going counterclockwise around the clock. Note from a scale degree that would be 1, 2, 3, 4, 5. Negative 5 scale degree. But we don't usually do scale degrees going backwards. So that's another place where the interval terminology falls apart, because when we go in reverse order, we don't really have a term for that. We'll get into that in a second, but just another problem to kind of introduce here. All right, defining the system. So in the new modal distance system, intervals are labeled using 2 data points. So if you were like a plumber or a woodworker or anyone doing a normal measurement, you're just trying to measure a map, you're a gamer and you're trying to see how far it is in Zelda or whatever the new games are. I don't even know. I played Zelda way back, before it was even online or anything, right? You're trying to figure out the distances between one thing and another. So it's the number of half steps. That would be like miles on a map. You're looking, half steps are the distance term. The number of modal half steps, that would be similar to if we had inches versus like a foot. So we have 2 units of measure, noting that that second unit of measure isn't perfect because it's not uniform. It's dependent upon where you are in the collection of notes that will be in order. But these are the 2 units of distance that make sense within our measurement tool that we can try to combine together. What might it look like? What you have is really 2 units of measure. It's a 4, 2 modal half steps. So notice our term before was a 4 note away major third. But the third represents a scale degree that counted the place that you started on. So all the scale degrees are really off by 1 from a measurement term. So if you see a third, really it's 2 modal half steps from that point. Now note that you don't really need to name the point. They call it a major third, as though the major is telling you where you're measuring from. But that's not always true, because you might not be measuring a major third from the 1 of a major scale. You might be measuring a major third from the 4th of a major scale or the 5th of a major scale. So the major isn't really giving you any more information. You could just call it might be better to call it a 4 note away major third. Or more precisely or accurately, using proper measurement like a plumber would do, it would be a 4 note away second modal half step. Right? And so then in order to differentiate these 2 notes, we might as well put another letter. I don't want to put a major in between them. I might as well put the place that we are measuring from, which if it was a major scale, we call that the Ionian mode. From a Nashville number system, it would be the first. It would be 4 notes away from the first, and it would be a 2 modal half step up, which would be the third scale degree if we were thinking in scale degrees. So a lot of people are intimidated by the I here because they don't use Ionian. They basically see it as either a Nashville number system, which stays constant, or they're gonna see major and minor, and then possibly not work with the other modes much. But if you use a Nashville number system, notice that that's supposed to be easier. It kind of is, because it's more logical. So if you replace this with a 1, you would basically be doing a Nashville number system kind of concept. I think it's easier to use the letters and has more functionality. So I think it's useful to learn the letters and the numbering system, which is an absolute numbering system. So this would give us 4 semitones forward from the Ionian. That's what that 4 stands for. 2 modal half steps. That's what that 2 stands for, which would be the third scale degree, because the third from a scale degree term is always off by 1. It's too high by 1, and it's equivalent to the third scale degree. So notice that each of these notations has meaning to it. So you could drop it down to just an Ionian second if you wanted to, which would be equivalent to the third scale degree, which would be a major third from the point of the Ionian. But I think naming the four is a useful thing to do, and it gives you every term here has meaning to it that's meaningful almost all contexts that you're working in. Now you might say, hey, look, what if I'm not working in the context of an Ionian mode? Note that you can make that argument no matter what kind of context you're adding, whether it be scale degrees or whether you be talking about modal half steps. In other words, you might be saying, hey, look, if I'm just measuring from this note to this note, why do I need to be adding then modal half steps? You don't, right? Because that's going to be giving you an added context. But you also don't need scale degrees. Why would I say it's a 4-note away major third? If I say it's a major third, the third is telling me that I'm in some kind of collection of notes, and this is the one of that collection of notes. So that's what the scale degree is doing. If that's not the case, we should just say it's 4 notes away. But it's nice to have that context because in Western music, we are almost always in some 7-note collection. There could be 12 different 7-note collections. The reason the scale degree is not as efficient as the context of a modal half step is because we're not always measuring from the one of that collection of notes. We always do have 7 notes that we're kind of working in Western music, and they're always in order. That's true, but we're not always measuring from the one. So that's where the problem is. So in this case, if I'm looking at this collection of notes, this is the 1, this is the 5. So I could use the context of measuring up something similar to scale degrees, but I don't need to make that the 1. I need to just say I'm going up in context, 2 notes up from the 7-note collection of notes that are in order. All right, why is it better than scale degree system? So the current scale degree system is off by 1 due to starting at 1 instead of 0. So if this is going to be our collection of notes, we have 12 notes in the musical alphabet, and we pick out 7 of them. We talked about how to do that in a prior presentation. So now we have 7 notes. We usually work in the key of C, but any of the other 12 collection of notes would be all the same. So don't let it throw you off that we're always using the same kind of notes. It's the same all the way across. Now, if I was to number these notes, it would be 1, 2, 3, 4, 5, 6, 7. So the problem is if I'm measuring from this C to this F, then what am I going to call that? I have to call that the 1 to say it's 1, 2, 3, 4. But it shouldn't be 4 distance. The distance should be 1, 2, 3. It's a 3-note distance from these, what I would call nodes or modal points, 3-note distance up. Now notice that the distance between all of these points is not the same, because if I go from this C to this D, I have a note in between, whereas if I go from this E to the F, I don't. So I have to know relative position of the node that I'm going from, but it's always going to be in the same order. So therefore, it still would make sense for us to identify the node that we're measuring from and then count up from that node, so that if I'm measuring from this F and I'm going up to this A, then I can still say it's a 2-note away modal half step, right? Instead of saying it's going to be, I have to make that F the 1 and say that this A is going to be a major third. It's not a major third from the F because the F is not the 1 in our collection of notes here. We want to keep an absolute numbering or natural numbering system, in which case it would be 1, 2, 3, 4, or the Lydian node. That's the problem. It causes all kinds of problems that you probably are dealing with as you're mapping out on your instrument, particularly on the guitar, but don't really understand why you're having this problem. Why am I jumping from scale to scale? Why am I making this the 1? Why can't I count this up, just in terms of distance perspective? So it requires redefining the root with every scale shift. So what does this cause you to do? This means every time you go to a different chord or a different part of the song, even though you're in the same overall shape, you end up renaming the shape and then thinking about the distances as though they're different distances. The distances between the 7 points on the map are always the same. We want to name it in such a way that we optimize that tool. They're always the same. On the piano, it's a little different because your fingering is different because it's not a symmetrical instrument. But on the guitar in particular, it's always the same. We want to maximize that. You must build a scale before you can measure from it. So in other words, if I'm measuring from this F, even though it's the same collection of notes, I have to make it the one to measure from this F to this A. Why would I have to do that? So I'm gonna make this a major third. So there's two terms that don't make sense there. I'm making it a third, and it should be 2 modal half steps up, and I'm calling it a major third, but it's not a major third because I'm measuring from this note. It's the fourth. I'm measuring from the fourth, so it's a Lydian, right? It's a Lydian distance. So even if I made this the one, it still doesn't sound quite right to call that a major third from the one because this is the one of a Lydian mode, right? Which is a different collection of notes than an F major collection of notes. You see, all of these problems are basically happening because of that off by one terminology. We shouldn't have any of those problems if we just measured from that point. So in contrast, the modal distance system only needs a fixed point, the mode center. So again, if you were to reconstruct the system, you would just say, hey, look, there's 7 nodes within the system, like 7 points on a map. They repeat, right? They repeat on the map up here, but the map is the map. I'm not going to, once I've identified my 12 different vantage points as the world is rotating around, then I'm going to keep the names on the map the same. If I'm playing Zelda and I'm trying to memorize how to get from one place to the other place, I'm not going to rename the notes on the map. And it's even easier than a map because it's in a circle. It's in a block format. So I can only go distance clockwise or counterclockwise. Now there are other problems because I can go counterclockwise and I can have 2 kind of units of measure in notes as well as in modal half steps. And it is possible for me to go over an octave. What would that mean? If I go from this 2 to this 5, I can go 1, 2, 3 continents up, 3 modal half steps, or I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went around the block and back there again. So I could name that as just the local distance, 1, 2, 3, give me the flavor. Or I could say that the actual visualization is that there's a combination of a number line, a notes number line that goes up to infinity, down to infinity, and a clock format. So this, you can imagine this popping up in a 3D format, so it repeats going around in a circle, but it also has distance as it goes up and down pitch-wise in an infinite way. So it's a little bit more difficult that way, but again, that's the visualization that we want to basically have on the fretboard. Directionality. The traditional system lacks directionality. So a major third is always assumes to go forward 4 semitones. Now again, I'm sure that if you're playing the guitar, you have an issue with this or any kind of instrument because basically we're imagining our intervals are usually defined as though we're on a clock face, meaning they're going to repeat even as we go up the octaves. Now we could use compound intervals. We'll talk about that issue later, but usually most people, particularly on the guitar, treat all the intervals as though we're on one octave within the clock face and it just keeps on going around in a circle. But we typically only name them going clockwise around the circle. Now notice if you're on a block, if you're saying, I'm going to go around the block, there's 12 points on the block or 7 actual destination locations that I stop on my trip around the block. If I go 4 steps in one direction, then I can go 12 minus 4 steps in the opposite direction around the block to get to the same point. The current system doesn't really have a naming convention for going negative distance around the block. That becomes a problem. There's no natural language to describe one step backwards. So in the modal distance system, we have symmetry. Now, if we say, for example, that we're going to go -1i, and I'm going to call that negative flows through to the negative first modal half step backwards, which would be the second scale degree, then you have 1 half step backward from the Ionian or major node. So in other words, what does this term mean? This would be going backwards 1 half step. So if I'm on the C here and I go backwards 1 half step, I get to the B in terms of my notes this way, if I'm on this C, the B would be above it, or I go around in a circle to the B if I go backwards 1/2 step from what I'm going to call the Ionian node, which is going to be the map on our point, which is going to be our C in this case, and it's going to be 1 modal 1/2 step backwards, which would be if I'm on this B and I went backwards 1 modal 1/2 step out of the 7 note collection. Now, what if we had a scale degree? On a scale degree terminology, if I went 1 note backwards, it would be 1 scale degree backwards. So you would think it would be a negative second scale degree. In other words, if I'm on the C and I go forward 1 scale degree and I use that as my unit of measure of the 1, this would be the 2 or the second. If I go backwards, then you would think that the B would be a negative second scale degree. But we don't usually do negative second scale degrees. We actually dropped the scale degree terminology completely, in part because it's not symmetrical. It doesn't really make sense to go backwards and say it's a negative second scale degree because you would think that you can figure out 7 minus 2 to kind of get to the positive directionality, but you can't because they messed up the measurement term, because this should be 0.0 and you measure from it. Instead, they used scale degrees. In other words, if I used this terminology, a -1 from the Ionian node and then a -1 modal 1/2 step backwards, which should be the negative second scale degree, then 12 minus 1 would be 11 steps forward. So this would be equivalent to going around the block 11 steps clockwise, 1 step counterclockwise, or this is a -1 step back because that negative flows through. If I go 1 step modal 1/2 step back, that would be equivalent to 7 minus 1 or 6 modal 1/2 steps forward, which would be the 7th scale degree, right? So this makes symmetrical sense. You can't make symmetrical sense on a scale degree going backwards because the measurement is off and it gets all messed up. So if you go backwards, it's a mess. So it's equivalent to 11 note away Ionian 6, which would be the 7th scale degree. So we can just use simple math to go around the block one way, which has 12 points, versus going around the block the other way, which has 7 points around the block. So here's the issue. If I'm on the fretboard here, let's say I'm on this G and I want to measure to this D. So what's the distance? There's a distance of 5 between the strings typically. We'll talk more about that later, but 5, 6, 7. So I have a distance of 7 notes going up this way. And what would I call that? If it's a distance of 7, typically we're going to call that a 7 note away perfect fifth. But what if I count from this point, counting this way? Then I get a 1, 2, plus 5, or a -7. There's a -7 distance. But notice we don't normally say, there's no term to say -7. So what you have to do is kind of take the inverse distance, and I'd say, okay, well, 12 minus 7 is going to be a distance of 5. So if I measure from this D to this G, I'm going to call it a 5 note away, which would be a perfect fourth, even though that doesn't exactly make sense, because you can clearly see that the difference between these two is 7. Either positive, you can think of this as +7 versus -7, right? So it like because of the kink of the tuning, this is a 5 note distance here, or you could see it like here. If I was on this D and I went down, that would be 5 notes. That would be a 5 note away distance. But going from this D backwards, that's a -7 note away distance. So I would think from a practical standpoint, then you start to want to think to use the -7 and say, well, if I went back a -7 distance could be a perfect fifth, and a perfect fifth would be forward 5. So in other words, I would say from a practical standpoint, and you're using normal intervals, you want to remember both directions for both of the intervals, meaning a perfect fifth is either 5 notes forward or it's 7 notes backwards. But again, that's not how most people kind of use the terminology. They only think about the terminology as though we're going clockwise around the clock and not negative clockwise. So they're still going to say, like, this is a perfect, from here to here is like a perfect fifth, even though we're going backwards a -7 distance. We're going to think of it as though we went clockwise around the clock. All right, that's a problem. Notice that if you use the current R notation, we don't have that problem because you can clearly then have directionality and you can still apply the concept of modal half steps without having that issue due to the fact that you started on a 1 instead of a 0. So cleaner inversion logic. Traditional system, if you have a 5-note away, that is a 7 steps. So I'm sorry, a perfect fifth is 7 steps. Its inverse is a perfect fourth or 5 steps. So we start to think about these inverse distances. How do you get the inverse distance? Well, if a perfect fifth is 7 steps forward, 12 minus 7 would be 5 steps. And a 5-step distance is going to be a perfect fourth. We'll talk more about these inverses shortly. But if I had a 7I4, which is a 7-note away from the Ionian node, which would be a 4th modal half step forward, which would be the 5th scale degrees, that's 7 semitones, so it tells you the 7 up front, and it's 4 modal steps forward, which would be the 5th scale degree. Scale degree is always off by 1. So the inversion then, of course, makes perfect sense because I can just say, well, that's like going around the block that has 12 locations, and I can say 12 minus 7, therefore, would be 5. So the inversion would be 5 from the Ionian, and then it would be the fourth would be 7 locations around the block. So 7 minus 4 would be 3. So a 5I3, 5 semitones, 3 modal steps backward. So the logical and intuition is right here, 12 minus 7, and then the 7 minus 4. So if you do that up here, it doesn't quite make sense. It's confusing because, once again, you drop the notes. The notes are gone entirely, so you just have to know that a perfect fifth is a 7-note away perfect fifth, so that you can take the inverse in distance, which is 12 minus 7, to get to the 5, and then this 5 represents the scale degrees. So if you had a major key, then that would be the 5th, or whatever scale degree you're on, that would be the 5th scale degree. You would think there are 7 scale degrees. So you would think that you can take 7 minus 5 and get the inverse, but you can't. Instead, you have to use something like a 9 minus 5 to get to the 4. You see, that doesn't make sense logically. The reason that happens, once again, is because they started on 1 instead of 0. The scale degree started on the wrong number, which is causing all these confusions. Now, you can get around that. You could say, well, yeah, you just learned the rule that you take 9 minus whatever the scale degree is, and then you get the inverse. And it's like, okay, yeah, you can find workarounds and stuff, but you shouldn't have to. It should be completely logical. Like, I should be able to see it this way. Okay, if I go around the block this way, it's 7. Around the block the other way, it's 5. If I go around the block this way with this unit of measure, it's 4. 7 minus 4 is 3. That makes sense just intuitively. Again, if you're a plumber and you're going around the block, that makes sense. For this, you have to learn rules which you shouldn't need to learn because of the problem or the error that took place. So independence from scale construction. Traditional system requires creating a scale to derive intervals. So once again, in order for me to determine a distance term, I need to make a scale out of something I might not want to make a scale about. It's just a collection of notes. So for me to measure from this f, it doesn't make sense for me to make a scale from the f when it's the same collection of notes. I should just start from that point and measure from that point. So in the modal distance system, no scale required, just identify the modal node. All we have to do is say we have this collection of notes. This is the node that we are on. We're going to measure from that node, and we're always going to go directionally around the block, either clockwise or counterclockwise, but I can't go through the middle. I can't go like through the middle. It's always going around the block. So the intervals are consistent regardless of tonal context. All right, so all benefits, no loss. So again, you're probably thinking of this. You've probably thought about these ideas if you've worked with this for some time, and you've thought, well, there's got to be a reason. It can't be that there's a better way. Well, no, there is actually an easier way to think about it, and it's worthwhile to think about it in the cleanest way possible. And again, the rationale that you would possibly get to why it's not presented in the simplest way is historically the way it's been developed, right? It's just custom that happened. But you'll get further by trying to clarify the language in your mind so that you can clarify it and then bridge the gap for communication to be able to better communicate on whatever terms are being presented, taking any terminology given and looking at what is required from that terminology, like what's the useful information and what is the misleading information. Just like talking to a lawyer or a sneaky, super progressive person that everything they say is implying that you're this and you're that, and they're calling you all kind of names and these weird terms and stuff that you don't know what they're talking about. It doesn't, all those terms don't matter. It just matters what's the distance. Like, what is the relevant thing that they're trying to tell me here? I don't care about all the other garbage. But I want to hear the term to get the actionable information. And that's the same thing we want to do here. What is the actual useful piece of information? That's how I want to see it. You can call me all the names you want and all the other stuff that you're doing. That's fine. I just want to hear the relevant thing to get done what I want to do. So it does retain all the functional interval data from the traditional system, adds direction, consistency, and logical inversion, enables mathematical understanding and scale-free visualization. So again, it's just the common sense thing to do. The inversion, direction makes sense. If you go a distance above an octave in either direction, it's consistent mathematically and makes sense. We'll map all this out in detail. Integrates smoothly within modern tools. So if you want to convert, note that all music systems are logical completely, even more so than language, right? So the current system is logical. It's just not the cleanest system. You have to take extra steps to get there. It's like having 5 pages of code to do something when you only need like a paragraph of code. It's still logical. It still works. It's just not as efficient. And that also means that software, particularly like a ChatGPT or something, can do the conversion easily these days, which is why I really think there's no way that the current system is not going to change now. It's like it got frozen in time the way it was because of writing. So like language got frozen in time because of writing. So it used to shift all the time. But now it's being liberated again because we can translate using computer language, which brings us almost to a vocal or verbal place again. So there's nothing, we're not in the most efficient area, there's nothing that's going to hold us back from saying, no, we should do better because it's not frozen in time anymore. We can do the translation real time, anytime. So summary. The modal distance system avoids the off by one problem, which is clearly an issue. It enables directionality and simplifies inversion, which again, I think that's just self-explanatory. It detaches interval naming from key and scale dependence. It's a more logical, more teachable system for modern musicians. Now again, as you're thinking, you're going to be thinking, well, I don't want to learn more stuff, or I don't want to replace the current learning. Again, I wouldn't really say you can replace the intervals, but what I'm saying is you can add this to your term. Think of it as a different term. It's a modal distance, which is always going to be one less than the interval, right? It's always going to be one less than the interval, and you're going to be measuring that from the node, and that'll give you an easy comparison and conversion going from interval to modal distance, from modal distance to interval, and it'll allow you to then think of things in the more logical way, giving you some blockage in your mind against, the lawyer that's trying to convince you of something that isn't true, right? The language that's pushing you in a direction that is false. Just get the information you need.